That's 5 times 5 is 25. There's subtraction in the middle here. Comes down. And I've got 9 minus 5, which is 4. All right, next one. Square root of 9 plus the square root of 16. Square root of 9 plus the square root of 16. All right, square root of 9. Corey. 3. Square root of 16. Corey? 4. So I've got 3 plus 4 here, which is, of course, 7. All right, next. Square root of 100 plus the square root of 4. Square root of 100 plus the square root of 4. All right, square root of 100. Kevin?
50.
Nope.
Oh, no, 25.
Nope. Corinne? 10. 10 times 10 is 100. Square root of 4? 2. We add those together. And we get 12. Now, these last two are multiplication. Remember, multiplication, run them together first. You're allowed to do that. Because square root of 3 times square root of 3, there is no square root of 3. It's a decimal. We're not looking for decimals here. So run them together. Square root of 3 times square root of 3 makes the square root of 9. Now, the square root of 9 is something we can figure out. The square root of 9 equals 3. All right, and then the last one, square root of 2 times the square root of 8. 2 times 8 is 16, so that's the square root of 16. Square root of 16 equals 4. Good. Okay. Few more problems done for you, a few more problems for us to do, and then we're done. All right, now, this last column primarily involves adding and subtracting, not things that are perfect, things we have to think about. Again, we're not looking for answers that are decimals. Anybody could go into their calculator and punch in square root of 7 plus 3 root 7 and come up with an answer. We're looking for answers that have roots in them. Again, when we're talking about problems with roots and adding and subtracting, they have to have like roots. So for instance, as you see in example C, I've got 3 root 2 plus 2 root 2. If I have 3 root 2's and I add 2 more root 2's, I end up with 5 root 2. In D, I have 7 root 4 minus 2 root 4. If I have 7 root 4's and I take away 2 root 4's, I end up with 5 root 4's. Now, you can see that's the middle answer here. There is a slight simplification you can make here, like we did down there. Square root of 4 is a perfect square root. Square root of 4 is equal to 2. Right, so this is the same thing as 5 times 2. 5 times 2 equals 10. Now, the same person that asked me that genius question last hour said, well, wait a minute, why isn't it subtraction? Right, it was subtraction here, why isn't this? You're looking at this now. Right? This doesn't have a subtraction sign in it. You're simplifying this answer. You're done simplifying this. That's why this is multiplication. E, 2 root 3 plus 2 root 2. Well, root 3 and root 2 are different roots. I can't do that, so that one's no solution. Now, if I was asking you for a decimal answer, you'd come up with a decimal answer. We're not looking for that. We're looking for an answer with a root. So for us today, no solution. Now you're looking at F and go, well, wait a minute. There's different roots there. How did you come up with an answer? There is a possibility, a good possibility, because I know it's on homework, because I know the worksheet. There's a possibility that you could come up with a problem that can be changed to have the same root, which is exactly what we do here. What you want to do is you look at the smaller root. Okay? Here I happen to have root 16, and I go, oh, well, how can I get 16 out of the other number? Well, if I'm looking at 64, I'm saying, okay, 64 is the same as 16 times 4. Now, if I cover up the 16 part, that just comes out as a perfect 2, because the square root of 4 equals 2. So that changes into 2 root 16, and then you can add them together and you come up with 6 root 16. We'll practice that in these last examples because that is definitely takes a little bit of talent. Let's go to the first example there. 6. 4 root 17 plus 9 root 68. 4 root 17 plus 9 root 68. Alright, so underneath my root is 17. So I'm trying to work a 17 into here. Is something times 17 equal to 68?
No.
Yes.
Yes. What is it, Kaylee?
6.
Nope, too big.
3.
Nope, too
Oh,
small.
5.
Too big.
4.
4. 17 times 4 makes 68. Well, if I cover up the 17, I've got the square root of 4. Square root of 4 comes out as a perfect 2. So I'm actually going to bring 2 out of this answer. Now you say, oh, wait a minute, there's a 9 there. You just multiply them together. 9 times 2 is 18. So this is the same as 18 root 17. So if I have 4 root 17s and I'm adding 18 root 17s, how many root 17s do I have? 22. I have 22 root 17s. A lot of people screw this up and they say, they get the 22 part right, but they say it's root 34. The root stays the same. It's like the denominator in a fraction. It doesn't change. All right. 3 root 8 plus root 200. 3 root 8 plus root 200. All right, so the smaller root here has an 8 in it. So I'm going to try and do something with 200 that involves 8. 8 times what is 200? Not 7.
18.
Okay, it's 200. That means it has to end in a 0 or 5, guys. Let's think a little bit here.
40. No.
That's
No.
37.
25. I heard somebody say it. 8 times 25 is 200. Right. Now, if I covered up the 8, it'd say root 25. What's the square root of 25?
5.
5. So that's coming out as a 5. So that's the same as 5 root 8. So if I have 3 root 8s and I add 5 root 8s, how many root 8s do I have?
8,
I have
9.
8 root 8s.
8. Oh my gosh. I was right.
All right, next one. Root 352 minus